discuss our work, power and energy. Okay, so what is work? So work is defined as W equal to dot product of force into displacement. So that is F dot S, and for the dot product A dot B is nothing but A B cos theta. Okay, so W is equal to F dot S, Fs cos theta. What is power? Power is nothing but P is equal to W by T. Work done per unit time is power. What is potential energy and kinetic energy? So potential energy is nothing but this is the mgh, while the kinetic energy is, so here we consider two positions. Okay, so there are two positions, this is 1 and this is 2. Okay, so the change in potential energy is nothing but the final is mgh2 and the initial one is mgh1. So the net change in potential energy is nothing but mgh2 minus h1. Okay, so by bringing this change in potential energy, there is some work done. So what is the work done? So that work done is nothing but F dot dy, and the force is mg because the mass is mg. Okay, so this is, there is no sign of minus, this is plus. Okay, so mg dy. So by integrating this system, we found that this is mg h2 minus h1, so which is equal to the change in potential energy. So we can say that the change in potential energy, or in other way, the amount of change in potential energy nothing but due to the work carried out by this object. Okay, so our next topic is conservative force. What is conservative force? So in case of the conservative force, if the work done by the moving an object between these two positions is independent of the path, means you follow any trajectory, or anything, but the force remains same. So that is nothing but that is called as a conservative force. And if a mass is moving with some kind of velocity, so that kind of force is given by the kinetic energy of a body. Okay, so how can we convert this work is in terms of kinetic energy? So we know that work done is force into elemental displacement. Okay, so force is nothing but m dv by dt, and let's suppose the elemental displacement is dx. Okay, so here dx by dt, so dx dt move here, so dx by dt is v, so the work done is mv dv. Okay, and if we assume that the velocity of the particle is here v1 and reach to v2, so the kinetic energy, of this object is nothing but mv dv, and integrating this equation from v1 to v2, because v1 is initial velocity and v2 is final velocity. So by integrating this, we found that half m v2 square minus v1 square. So that is nothing but that is kinetic energy of the object. Okay, now the next topic is work energy principle. So according to work energy principle, the work is defined as dw is F dot ds. Okay, let's suppose this is, so if the work done is F dot ds and F is ma. Okay, and this is A is dv by dt, so multiplying by ds and divide by ds. Okay, so ds by dt is nothing but v. Okay, so this equation turns to be mv dv by ds. Okay, so the dw is mv dv by ds and ds. Okay, because if we displace this object from this small distance ds, then the work done is mv dv by ds into ds, and this ds is cancel out. So again we integrate from this position 1 to 2, this dw is comes to be 1 to 2 mv dv, so that is half mv square. Okay, and by integrating this equation, this is half mv2 square minus half mv1 square. So here we directly see that this is your work and this is your energy of the object. Means we can directly convert the work in terms of energy. So this is our work energy principle. And now the next topic is conservation of mechanical energy. What is meaning by conservation of mechanical energy? The simple meaning is that in the conservative force field, the work done in moving an object from position 1 to position 2 is independent of the path followed and depends on a change in the potential energy of the states only. Okay, so the work done is W212 is given by change in highest potential energy is at about position 1. If you suppose this is your position 1 and this is your position 2, so the mgh1 minus mgh2 is your the change in potential energy, and kinetic energy is, if here v is 0 and here v is equal to some kind of velocity v, so the change in kinetic energy is final minus initial. So kinetic energy at second position, kinetic energy at one position is equal to potential energy at first position and potential energy second position. So by this we can say that the total energy at first position and total energy at second position remains constant during the motion. Okay, so that is the conservation of mechanical energy. Means energy neither be created or nor be destroyed, but it can easily transform from one phase to another phase. Okay, so how can we proceed? The simple thing is that, let's suppose there is a simple problem, this. Okay, so here this is a position, this is B position, and this is C position, where total height is h, this height h1, and this height h minus h1, and this is second point. This is the ground. Okay, so how can we determine the mechanical energy? So first, there are two kind of energy. One is kinetic energy and second one is potential energy. So, or maybe you can say this is position 1 and this is position 2. Instead of ABC, we assume that this is first position and this is second position. Okay, so now from the starting position, the kinetic energy of the body is half mv square. So v is equal to 0. So the total kinetic energy is 0 here at this position, and potential energy is, since the total height is h, so the total potential energy is mgh. So the total energy is kinetic energy plus potential, that is mgh. Now come to the position 1. This is, so according to equation of motion, v square equal to u square plus 2gh, and since here starting velocity is 0, so by this equation we found that v1 is under root 2gh1. So the kinetic energy is half mv square. Okay, so half mv square, and by putting this value we can found that this your total kinetic energy is mgh1, and the potential energy is, because this is one position and this is h1 height, so this is h minus h1, so mg h minus h1. So the total energy is, again this will be cancelled out, and this here comes to be mgh. Now at position 2, so at position 2 again this velocity is under root 2gh, because the height is h, so the kinetic energy is mgh, and since there is no any height, because at this position no height, so h equal to 0, so the potential energy is 0, and again the total mechanical energy is, again this is mgh. So means your total mechanical energy remains constant in the action of gravity of force. Okay, so thank you.